Hello everyone, welcome back to my channel again. Today I'm going to share with you one of the test projects I've done recently, which is designed to prompt a large language model with the same question several times and to see how the questions disperse in the space. So basically this idea came to me when, like months ago, in different social media platform, people are discussing about the accuracy of the large language model and about if the RAG flow or some additional design would actually make the large language model more reliable. So I guess this will be a start point to um, to test the large language model. Of course, this is a very basic format, so it cannot match to a very specific use case. But I just wish that this kind of test would give you some idea or inspiration to do further tests on large language model. The first thing is to install the different packages needed for this test. So I'm not going to go over everything. You can just check by yourself. And the most important thing is that I use Grok because it has very fast inference inference efficiency, and it can save a lot of time. And I also leverage the Google Cloud, the Colab environment to implement this test. Okay, so basically installing all the dependencies using Colab. I also saved my Grok API key here. The Grok API key actually you can get from the Cloud Grok platform. It's very intuitive. You can get it and use it. Uh, then I start by defining, first of all, is calling the Grok model. This is a function. Then there's get embedding. So it's not very complicated, right? We just prompt the same thing to the model for several times and to see how the response is getting feedback. But you already noticed that here, I did not specify the temperature. I do not have a rag flow to actually do a test to compare two groups of the different model design and the different answers. So this is a basic model, like I said. I just want to fast test and see if some of the visuals and the general design works. So we also come down here, you see, to initialize the tokenizer and the model for embeddings. So basically, these models are useful for me to transfer the text information to vectors. Okay, just simply put like this. Then about the main part of the code, first of all, I have the different prompts ready. Okay, these prompts are not designed by me. Okay, so basically, for my personal use case, I never would like to write a short story, like some sci-fi story using LLM. I would like to read somebody's book or check or watch a movie or watch a TV series, but not to talk with a large language model. But I let ChatGPT to design these questions, um, just to see how it goes. And the number of repetitions, I want to see 10 times of the different responses. So I 10 will be the threshold of the for loop. Um, and then you can see we're going to save our embeddings and also the responses because I also want to see the embeddings. These like the vectorized information for each response, of course, we can do further work on it. But to be honest, if the dimension is very high, to actually capture the essence of this information, the best way is to do the dimension uh, reduction, like use principal component analysis (PCA). So when I use PCA as 2, it crushed the vector space to get 2 dimensions. When I crush it with PCA 3, actually all the information is condensed to a 3D space. So in both way, I'm going to see how the distance how they are dispersed. But now I only get a graphical idea. I do not have a measurement of the different distance between these dots. So to actually see a more complex result, more numerical and more robust result analysis, this test is not enough. Okay, we can do many more things. But here I just prompt, get responses, transfer responses to vector space, show it in 2D space, 3D space. That's it. Okay, so basically in here, the inside for loop is actually to call the model and get response. Okay, and also append the embeddings, those responses. And eventually, I also print some of the information for me to check. But to be honest, if the response is very long and not, let's say, it's not well designed or contained, for example, you want every response to be limited to 500 words, something like this, it's very hard to see the difference because it takes, if you use your human judgment to evaluate a 500 words long paragraph or a story, one from another, it's really hard. So in that case, I think the embedding results, the vector value results, could be a way for me to understand the distance between the two results. But let's see, it only gives you a general idea and nothing more. But I think this could be a good start. So in the later part, you can see there are 2D data and 3D data to actually print them in 2D and 3D space. For me, really, generally speaking, I think because our limitation of understanding the graphical information, 2D and 3D space are the maximum because visually we cannot. For me at least, I do not understand how to represent this 4D space. Maybe from a sequential 3D space or from some other representations that requires more profound understanding of data and machine learning and so on. So let's see. So basically, the first question is to ask the large language model to write a short story about time traveling cat who visits ancient Egypt and befriends a pharaoh. It's very nice prompt, I see. And you can see the large language model without setting any parameters. It's very creative, and it actually created a short story. So I'm not going to go to the detail. If you want, you can check and get a sense of it. But to really understand and interpret it by human for several chunks, documents with very long length, it's really time consuming. So I'm going to jump to the second part of the embedding. And you see, to transfer this whole passage to embedding to the vector space, it's very complicated. See, it's very long, a long list of numbers. And for a response, so I print only 5. So let's see. For the first question, we get all these responses. We can see that some of the responses are very close to each other. So, which means that let's see the general pattern large language model. We can actually summarize to different categories. It's like this one is the main part in the middle, and the others are outliers. But you see, if you do not contain the large language model, either using RAG, either using chain of thoughts, there are many different tools to implement the tool calling and different methods to make sure large language model is more reliable. Without those tools, the results you see from a large language model are very dispersed in the vector representation or in the 2D space, in the 3D space. So as you can see, just intuitively we'll understand that there are some outliers and some of the responses are very concentrated, right? So if you change the temperature, if you change how the large language model is getting the response, results are going to change. So based on my understanding now in the market, there are some people who like to use large language model for enterprise use case. So even for query, like a large language model to query language like a SQL, its reliability is key. So in a very specific use case, the accuracy should be 100% because you don't want a large language model to go play with the whole workflow and generate a very simple query, okay, with error. Like I want to query company A 2022 net profit. It should be a fixed number because that's it. It should not be ambiguous. So in this case, after seeing these results, I think with or without a very robust RAG flow, I think no matter what is your use case, first of all, you need to identify the accuracy requirements. For example, if you just want to get inspired, of course, you can let the answers fly. But if you want a specific query, like a SQL query, the results should be very accurate. So this kind of test, I think, could give us some idea. So basically, based on this 2D representation, you can do clustering, you can analyze dispersion, and if you really have large computer resources, you can actually test many times to see the dispersion. So this idea is actually partially inspired by one of the paper to discuss the different response. I think malicious response from large language model and their dispersion. So basically in that paper, eventually it has to crush this huge list of number to 2 dimensions, 3 dimension, to let us understand, to better get a sense of how the responses are dispersed in the space. And following the PCA 2-dimensional graph, I also simulated randomly some of the number to give you a sense that if the results are really random, actually the dispersion in the 2-dimensional space is more dispersed through the space. This is only for showing the idea, but it's not related to the test data. Then here, this is a 3D vector graph that is simulated by the random number. So as we can see, if we are seeing a really random result distribution, the points are very different and dispersed in the 3D space. So based on this, we have an expectation that the large language model should have a not so well clustered results. So let's see the next part. For the other question and response, of course, you can check. But the general idea is that we get a response to the vector, map it to the space, and to get to random vector sets to let you get the idea how the really random numbers could be. So now we go to the dynamic 3D display part. Of course, we use Plotly package, and we now crush our data to a 3D space. So in this part, I do not show the textual results because I think the 3D graph should give us the idea. So basically, each question has got 10 responses from large language model. This is the first one, and this is the second prompt, and this is the third prompt. As we can see, if we actually make our space into another dimension, the distribution is how can I say, is more dispersed through the space. You see, there are not. Yeah, you see in the middle, maybe there are some points that's very close for specific prompts, but in general, it is more dispersed in the 3D space. And we can see that for a different prompt, which got generated different responses, they could potentially get very close. So this is very interesting. It really encourages me to do more tests about a specific use case to actually understand how these responses are dispersed. So basically, without dig deeper to the training, to the building of large language model, or fine-tuning to make it more accurate, or to add additional workflow to it, after this test, one thing is for sure. I think to understand the large language model's answer distribution, the best way is to test with a very specific question and see how they dispersed. But I think only relying on the embeddings, there are maybe some of the semantic information or meanings, different textual information you cannot capture. So I also doubt that if the distance is this far away, does it really mean these two answers are really different? So we need to find more ways to actually get an insight of the differences of the different data points. Okay, that's all for today. So today I have showed you test I have done is to actually prompt a large language model to get a series of responses and use the embedding model to transfer them to high dimension vector space vector and to crush it to 2 dimension or 3 dimension. Okay, so you can see the difference of different response. So based on this, it will give you a good start to get deeper understanding of large language model, especially if you are like me, who is very interested to understand how the large language model perform. I think this is most intuitive way. When you actually go deeper to go to like the fine tuning and the different workflow design, it will create more, like I say, the more chance for you to better utilize large language model, but you need to test it. Even with RAG, with like one of the products called Perplexity, I remember. It is actually very famous for its RAG flow. I think it actually falsely puts all the citations to each answer generated by the platform. But even that kind of software can hallucinate. One day I just asked a very simple coding question. It actually gets to a very simple loop. So this really makes me think if a large language model cannot be always 100% using different combination of tools, we always need to understand, to test, and also to, if you are using it in your production case, always make a good ledger of all the results generated. That's very important for you to keep track of the performance, how you choose the model, how you fine tune the model, how you build a RAG flow, and so recommendation to all the audience. Do some tests and see how the large language model works. See you next time. Bye bye.